So can we quantify? The answer is yes. Okay? And that's what we're going to look at next. All right? So I'm going to put this PowerPoint back in play. Let me put it, there we go. Let's see. Let's quantify. So now we need something to make up for the scatter plot. That'll help support the scatter plot, because scatter plot shows us the relationship, but it doesn't quantify. It doesn't tell us how strong that relationship is. Now, in the quantify realm, there's something we can calculate. And that something is called correlation coefficient. Whoa, I know. Look at that. Look at that big old formula. It's only big because I stretched it. I mean, but it's not a bad formula. It's not a bad formula, actually. Okay? So, we saw, hold on, we covered this. We covered this before. Summation x squared? Yeah. We covered what these terms mean, right? Yes. All right, okay. So, okay, just want to make sure. So yeah, you can calculate correlation. This is called Pearson's correlation coefficient. This is the formula, okay? And what you're doing is you're calculating a value, one value, and that value tells you how strong of the linear relationship between x and y. Now, just so you know, n is sample size, so it's number of observations, right? And then summation x means you would where's the data set? Where's the data set? So if this is x and that's y, summation x means add up these data values, right? Summation x squared says square each data value and then add up the square values. So like summation x would be 4 plus 3 plus 3 plus 3 plus 3, da 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 da. Summation x squared will be 16 plus 9 plus 9 plus 9 plus 9 plus 9. Da, da, da. Is everybody with me? And you add those up. And then same for summation y, you just add up these values. But summation y squared means you got to square that value plus square this value plus square this value plus square this value and all the way down. All right, and then like I said, n is the number of rows of data, the sample size, which I think was 187. Am I correct? Did it say? Did the scenario? I think the scenario. If we don't, hold on. We don't know. It's right here. We just go back. So I'm going to close this for a second. You just scroll down. Just scroll down. Eventually, let's see. 187. 188. 188. So n is 188. Is everybody with me? Okay, I'll talk to myself. All right. Okay, so like get to the point. So R can be calculated. Of course, this can be done in StatCrunch. I'm going to show you in just a second. Okay. Keep in mind that R is sensitive to outliers. So remember that point that we saw, that observation that we saw, that influential observation that we saw. That can skew R. But it's not going to make a big impact because it was only one observation out of, 188. It's not going to skew it that much, okay? But if we had a cluster of them up there, now that would be something different. That can affect R. And so what happens is you can calculate what's called an adjusted correlation coefficient, where you take those observations out. You see what I'm saying? You take them temporarily, take them out, and recalculate R. All right, but we're going to keep it in. That's going beyond the scope of this course. We'll keep those observations. R can take on values between -1 and +1, including -1, including +1. But the reason why I put a circle here instead of making it like a bracket is because very rare chance that you will calculate an R of -1 or +1. Okay, very rare chance. You're more likely going to calculate a value that'll be strictly between -1 and +1. But again, the higher or the closer R gets to +1 or -1, the stronger the linear association. Now, the sign of it, either positive or negative, will determine if you have negative linear association or positive linear association. Close to 0, R being closer to 0, shows weak association, linear association between the independent and dependent variable. It is custom to round R to 4 digits after the decimal point. 4. Okay. All right. So going back here. Okay. So going back here, let's open up. Let's open up Stack Crunch, and I'm gonna show you that I actually calculated it. Okay. I actually calculated it, boom, 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 and I got 0.6277. Now what I did was I calculated each piece. So I calculated this, what that answer was, I calculated this piece, and then I calculated what this was equal to, and then I calculated this equal to, and then put the calculator. Okay. So I got 0.6277. Now, I'm gonna show you now how to get it. Okay. But please keep in mind that if you have a question like this on the final exam, I'm not going to give you something with really big numbers. I would probably give you just a very small data set. So do y'all want me to give you a quick practice problem of if this were a question on the final? Okay. All right. So let's do. I'll sit in Alberto's chair. I shall fart in his chair.
He's gonna think you're.
All right. So suppose we have X and Y. So this is our independent variable. This is our dependent variable. Okay. Okay. And then I'll have 1. Let's say 2, 6, 7, and 9. And then here we get 0, 3, 5, and let's say, let's go 4. Okay? And so here are your two variables. I'm giving you a type of question that I would ask on the final. Okay? So let's do this problem. So let's say we want to calculate R, correlation coefficient. Okay? So Michael, give me a blue marker. Can you reach in that black bag and give me a blue marker? You can throw it. I'll catch it. It's not gonna hit them. It's not gonna hit y'all. I promise. Okay. I promise it's not gonna hit you. Come on. Let's go. Let's go. I was gonna say. Let's go. Okay. So in this problem, what is n? How many rows of data we have? 5, right. 1, 2, 3, 4, 5. How many pairs of data? 5. So n is equal to 5. Is everybody with me? Yeah. All right. Now, in order to use that formula, we need summation x. Okay. So I'll do this. I'll put summation here. Okay. I'm gonna put a line. Okay. All right. Now, so we have x. We need summation x squared. Because you see, look at that first square root in the denominator. We got n times the summation of x squared. So that means we got to create an x squared column. So in between, I'm going to call this x squared. And if you wrote it over here, if you want to write x squared over there, that's fine. Okay? I'm just putting it here since it's next to here. Okay, so x squared column means I got to square each of these values. Is everybody with me? So tell me what to write. 1, 4,
36,
36,
49,
49,
81.
and 81. Good. Is everybody with me? All right. And now, and then we have a summation y. We have the y column. But we have a summation y squared. So we have to make a y squared column. So we got to square these values. Tell me what to write. 0, 9, 25, and 16. That's right. Now, there's one more summation up on that board that we haven't looked at. Look at the top left-hand corner. Summation xy. You see that? So we have to make an xy column.
Oh, man.
That's not that bad.
No,
So that means I'm going to take the x times the y. So this will be what? 0. This will be 6. Keep going. 18.
35.
35 and 36. Good. Okay. You have to make those columns before you can make the summation, find the summation. Now, we're going to do some adding. So this will be what, 3, 9, 7, 16, 16, not 25? Okay. So this is the value of summation x. You see that? All right. Okay, don't judge me, hold on. Oh, don't tell me. 130. 130, 166, 171? I got 171. Somebody check my math.
90 plus 81.
Yeah, this is
Yeah,
130.
90 plus 81, 7.
130, 166, 170, yeah, 171. Okay. This is what, 3, 6, 10, 15?
Yeah.
Okay. This one is 41, 50, 59?
Yep.
Okay. I'm gonna put 2 lines, because 2 lines usually means like add. Okay, and then finally, that XY, that's 71,
90,
89 and 6,
93.
89 and 6, 95?
Yeah.
95, okay. 95. And these are values I'm gonna need to calculate R, okay? All right, so I'm gonna come behind you if you don't mind. Okay. Why you say it like this? You look like that. Okay. This is my classroom anyway. All right, good. You don't have to move. No, you don't have to move. I'm fine. Yeah, I'm fine. I'm fine. So now, to calculate R, I'm gonna put the formula up first. So it's N times summation XY, sorry for my summation, minus summation X times summation Y over square root of N times, I used to memorize this formula by heart, don't judge me, minus summation X squared times another square root, N times, we had to memorize this in grad school, Y squared minus summation Y.
Is that XY or
This one? This is summation, this one? This is summation of X times Y
Square.
together. This is summation XY. Summation XY,
Okay.
okay? All right, so let's do it. So R is equal to, what is N? 5, correct. What is summation XY?
25. Oh,
What is this
95.
value? Summation XY.
95.
95, correct. See, summation XY, find the connection. You see that? Minus, what is this?
25.
25. Summation Y,
15.
15, excellent. Over the square root of 5 times, what is this?
171.
171. Minus, what is this?
25.
25 squared, right, it has to be squared. Let's see, summation X quantity squared. Times the square root of 5 times summation Y squared
59.
is 59. Minus
15 squared.
15 squared, that's right. Okay. Okay, this is, don't tell me, hold on. 4, don't tell me, 45, 25, 475,
Yes.
450 plus 25, 475?
Yes.
Yes.
475. This is, don't tell me, 250 plus 125, 375?
Yeah.
Alright. 25 squared is, 25 squared, don't tell me. 625. This is 625. This is,
Oops. Dang it.
so this is 625. This is 85, 850, 850 plus 5, 855.
Mhm.
So that's 200, 230. So this is square root of 230. And then this is 250 and 45, 295. So that's 295 minus 225, 70. This is set square root of 70. Check on math. Check on math. Let's- So
625. 55 minus
Alright,
625.
so
230.
quick, and then we'll hit a break in just a second.
Yeah.
100.
Yeah, we're about to hit a break in a second. I just want to finish that up. Here, now, Cam. So the way you put that in, you can do this. 475 minus 375 divided by.
Minus
Now you have to put the denominator in parentheses. The square root of, what was that? 230 times the square root of 70. Was my math correct over there then?
Yes.
Okay. 0.7881. Oh, that's not a bad correlation. That's not, wow, I did a pretty good job with correlation. So we get R equals 0.7881. By the way, 0.7 or higher is evidence of linear relationships. 0.7 or higher or negative 0.7 or lower. Okay? So 0.7 is a good correlation. So R equals 0.7881.
Will you say that one more time, the verbiage of that? 0.7 or higher is?
Yes, in published documents, if you ever publish like work or technical paper or something, 0.7 is the standard in industry and in academia for showing a strong relationship between two variables, strong linear association. 0.7 is the standard. Yeah, go ahead.
Sorry.
You're okay.
Right,
So hungry.
yeah, when I mean 0.7, I'm saying 0.7 to 1 or negative 0.7 to negative 1. Any of those, thank you. Thank you for pointing that out. Yeah, 0.7 or higher or negative 0.7 or
There
lower.
we go.
So if you get that, if you ever do any research, whether in your field or whatever, if you ever report 0.7 or higher, you can say already we see, good evidence suggesting that these two variables are correlated. Before you even do the hypothesis
Second,
test, right?
230.
You can say that. All right.
Second.
Okay, and then, okay, so last thing, I just want to show you how to calculate it in here. So really quick, so you're gonna go to stat, you're gonna go to regression, and then simple linear. Oh, sorry. Oh, let me do it again. Sorry. Stat, regression, simple linear. And then up here, X was what, PG waves,
0.788.
and then Y is episode total. And then we'll talk about all of this later, but just right now, because this is coming up, this is gonna be the latter part of this PowerPoint. But just hit compute for right now. And then it's right there. Correlation coefficient 0.627. All right. Everybody see that? And it matches up. Okay. Let's take a break. Let's take a break.